Hi students, in this video, you're going to learn your 12th lesson, Indices. By learning this lesson, Indices, you will be able to identify the laws of indices on the product of powers, the quotient of powers, and the power of a power. And also, you will be able to simplify algebraic expressions using the above mentioned three laws of indices. Additionally, by this lesson, you will be able to identify the zero index and the negative indices and also to simplify algebraic expressions containing the zero index and the negative indices. First of all, in the lesson indices, let's have an introduction to power, index, and base. Let's say we need to write 8 in index notation. So first of all, we can write 8 as 2 times 2 times 2, and that can be written as 2 to the power of 3. And here in 2 to the power of 3, 2 is the base, 3 is the index, and in totally 2 to the power 3 can be called as the power in index notation. Let's try another example. Let's say we need to write 81 in index notation. So first of all, we can write 81 as 3 times 3 times 3 times 3. And there are 4 threes, so we can write it as 3 to the power 4. And in 3 to the power 4, 3 is the base, 4 is the index, and in totally, 3 to the power 4 can be called as the power. So let's have a revision about what you have learned for indices in grade 8. Here guys, you need to write products in index notation. In the first problem, guys, you can see there are 3 5s. So we can write this in index notation as 5 to the power 3. In the second one, we can see there are 4 minus 5s. So we can write it in the index notation as minus 5 to the power 4. And in the third one, there is a fraction. The fraction is 3 over 4. And there are 4 3 over 4s. So if we write it in the index notation, we can write it as 3 over 4 to the power 4. And in the fourth one, we can see there are 5 x's. So in index notation, it can be written as x to the power 5 because there are 5 x's. And in the last one, there are 4 pq's. So we can write it as pq to the power 4. In the next one, you need to expand the given powers. The first one is 5 to the power 4. Here we can see there are 4 5s. So we can expand this like this. And in the second one, there are 3 minus 2s. In the third one, there is a fraction 5 over 8 to the power 3. So there we need to write 3 5 over 8s when we are expanding the power. And in the fourth one, there is once again a fraction, and that is a negative fraction, that is minus 2 over 3, and there should be 2 minus 2 over 3's because here the index is 2. In the fifth one, that is x to the power 4, that means the index is 4, so there should be 4 x's. In the next one, the index is 3, and so there should be 3 3y's. And in the last one, the index is 2, 3pq to the power 2, so it should be written like this. So that's all about expanding powers. Yeah, that's the end of the revision. Let's learn the first concept in the lesson, products of powers with the same base. Here we can see the first power is 3 to the power 2. So 3 to the power 2 can be written like, and here we can see the second power is 3 to the power 4. And 3 to the power 4 can be written as 3 times 3 times 3 times 3. Next, we need to multiply 3 to the power 2 by 3 to the power 4. And here we can see both the powers are having the same base 3. So let's see how we're going to multiply these two. So in total, we can write it like this. There are 6 3's. So if you write it in the index notation, the result can be written like this, 3 to the power 6. So the answer for 3 to the power 2 multiple 3 to the power 4 is equals to 3 to the power 6. And guys, with this, there is some special thing you need to note it down. That is, this 6. This index 6 is actually equals to the sum of the two powers of the two bases. That means this 6 is equals to 2 plus 4. The sum of the two indices of the two powers which we multiplied initially. So with that, we can build up a law for indices. That is, if we take the product of two powers with the same base, the index of the answer is always equals to the sum of the two indices of the two powers which we are multiplying. In simply, we can say if we are multiplying y to the power n by y to the power n, so that is equals to y to the power m plus n. So that is the first law of indices, and that is the law of indices which is relevant to the products of powers with the same base. Now let's try out an example with the studied law of indices. Here we need to multiply 2p to the power 3 by 5p to the power 4. And here first of all we can see there are two numbers. So first of all we need to multiply the two numbers 2 and 5. And after that we can see there are two powers. P to the power 3 we need to multiply by p to the power 4. And here we can see both are having the same base p. When we are multiplying the two powers, what actually we need to do is to add the two indices. That means 3 plus 4. So here 2 into 5 is equals to 10, and p to the power 3 into p to the power 4 is equals to p to the power 7. So finally, the answer becomes 10p to the power 7. Let's try out another example with the same law of indices. Here we need to multiply p to the power 3 by q to the power 2 by p to the power 2 and finally by q to the power 4. And guys, here we can see there are two bases p and q. And the indices which are relevant to p are 3 and 2. So we need to get the sum of 3 and 2 in order to have the index of p, and we need to get the sum of 2 and 4 to have the index of q in the answer. So finally, the answer becomes p to the power 5, q to the power 6. Now let's try out a new concept in the lesson. Quotient of powers with the same base. Here we can see the first power is 3 to the power 4. So 3 to the power 4 can be written as, and the second power is 3 to the power 2, and that can be written as, and here we need to divide 3 to the power 4 by 3 to the power 2. So actually that is equals to, so by simplifying this, we can have 3 to the power 2 as the answer for 3 to the power 4 divided by 3 to the power 2. So here guys, we can see in the answer the index is 2, and there is some special thing with this index 2. That is, this 2 is actually equals to 4 minus 2, or the difference between the two indices which we have divided initially. So with that, we can have a new law of indices. That is, if we take the quotient of powers with the same base, So in the answer, actually the index is equals to the difference of the two indices which we used initially for the division. So simply, if we are dividing y to the power m by y to the power n, that is actually equals to y to the power m minus n. That means index is actually equals to the difference of the two indices m minus n. So guys, that is the second law of indices which we've learned under the lesson indices, and that is the law of indices which is relevant to the quotient of powers with the same base. So let's try out an example with the studied law of indices. Here we need to divide 4p to the power 4 by 2p to the power 2. And first of all, there are two numbers, 4 and 2. So first of all, we need to divide 4 by 2. And next, we need to divide p to the power 4 by p to the power 2. Here guys, we can see there is the same base p, and we need to have the quotient of the two powers with the same base. So here the power becomes p and the index of the answer becomes the difference of the two indices. That means 4 minus 2. So finally 4 divided by 2 is equals to 2, and here 4 minus 2 is equals to 2. So that means finally the answer is equals to 2p to the power 2. Let's try out another example. Here we need to divide p to the power 5 q to the power 8 by p to the power 2 q to the power 4. Here we can see there are two bases p and q, and the indices which are relevant with p are 5 and 2. That means first of all we need to have the difference between 5 and 2, 5 minus 2, and for q, that is 8 minus 4. And finally, for p, the index becomes 3, and for q, the index becomes 4. So the answer becomes p to the power 3, q to the power 4. So now we're going to learn a new concept under the lesson indices. This is about negative powers. Here, first of all, you can see there is 3 to the power 2, and in the second one, that is 3 to the power 4, and if it is 3 to the power 2 over 3 to the power 4, so that can be written like this. So by simplification, we can have the answer like 1 over 3 to the power 2. So here by simplification, we get the answer for 3 to the power 2 over 3 to the power 4 as 1 over 3 to the power 2. And here we are going to have the answer for the same problem but with a different method by using the laws of indices. Here we are having 3 to the power 2 over 3 to the power 4, the quotient of powers with the same base. The base is 3, and now we need to have the difference between the two powers, 2 minus 4. So that is equals to minus 2. So by the laws of indices, we can say 3 to the power 2 over 3 to the power 4 is equals to 3 to the power minus 2. So here, for the same problem, we get two different answers by the two different methods. By the laws of indices, we got the answer 3 to the power minus 2, and by simplification, we got the answer 1 over 3 to the power 2. So that means, guys, we can say both these answers are equal. That means we can say 1 over 3 to the power 2 is equals to 3 to the power minus 2. And here you can see there is a negative index, that is minus 2. That means that is a negative power. So finally, we can say under negative powers, if that is y to the power m, so it can be written like this, 1 over y to the power minus m. By using the negative powers, we can write y to the power m as 1 over y to the power minus m. And also, if it is y to the power minus m, So it can be written like 1 over y to the power m. So if it is y to the power minus m, it can be written like 1 over y to the power m. So guys, let's try out to sort out an example with negative powers. Here there is 3y to the power 2 multiplied by 2y to the power 3 over 3y to the power 7. So first of all, in the numerator, there is a multiplication between two powers with the same base, and there are two numbers also, 3 and 2. So first of all, we need to multiply 3 by 2, and that is equals to 6. And next, there are two powers, and the bases are y, and the indices are 2 and 3. So we need to add 2 and 3 in order to have the index of the answer, and that becomes 5. So the numerator becomes 6y to the power 5, and the denominator is the same denominator, that is 3y to the power 7. Now guys, here we need to divide 6y to the power 5 by 3y to the power 7. There are two numbers, 6 divided by 3, that is equals to 2, and there are two powers with the same base which needs to be divided. So y to the power 5 divided by y to the power 7. So the base is same, that should be y, and we need to subtract 7 by 5 in order to have the index of the answer. So 5 minus 7 is equals to minus 2. So finally the answer becomes 2y minus 2. And here guys, you can see there is minus 2, that is a negative power. And this negative power can be written using the positive powers. We can write 2y to the power minus 2 as 2 over y to the power 2. So the answer becomes 2 over y to the power 2. Here the first power is 3 to the power 4. So it can be written like this. And once again 3 to the power 4. The same way we can write. So after that, we need to divide 3 to the power 4 by 3 to the power 4. And so, in the numerator, it should be like this. And the denominator, once again, should be like this. So, by simplification, we can have the answer for this. And that is equals to 1. And let's try out the same problem, but with a different method by using the laws of indices. Here guys, there is a quotient of powers with the same base. The base is 3 and the two indices are 4 and 4. That means we need to subtract 4 by 4 to have the index of the answer, and that is equals to 0. So by the laws of indices, 3 to the power 4 over 3 to the power 4 is equals to 3 to the power 0. So now we have ended up getting two different answers for the same problem by using two different methods. So by the laws of indices, the answer was 3 to the power 0, and by simplification, the answer was 1. So that means guys, these two different answers are actually equal. So we can say 3 to the power 0 is equals to 1. And here we can see the index is 0. Yeah, so then that's about the 0 power. So the 0 power of 3 or 3 to the power 0 is equals to 1. And guys, that's not only for 3. So in simply, finally we can say if it is y to the power 0, so we can say it is equals to 1 in maths, where y is any number except 0. So now let's try out an example with the 0 power. So here we need to multiply 3y to the power 4 by 2y to the power 3, and the denominator there is 3y to the power 7. So here, first of all, in the numerator, there are two numbers, 3 multiplied by 2, that is equals to 6, and y to the power 4 into y, and y to the power 4 multiplied by y to the power 3. So the base is common y, and 4 plus 3, the index becomes 7. And the same denominator, 3y to the power 7. And now there are two numbers, 6 divided by 3, that is equals to 2, and the quotient of two powers, y to the power 7 over y to the power 7, y to the power 7 minus 7, and that is equals to 0. So finally, the answer becomes 2y to the power 0. And here guys, you can see that is a 0 power. And y to the power 0 actually is equals to 1. So the answer is equals to 2 multiplied by 1. And finally, that is equals to 2. So the answer is 2. So now we have come up to the last concept of the lesson, that is power of a power. Here we can see there is y to the power 2 to the power 3. So there are 3 y to the power 2's. And you already know y to the power 2 is equals to y multiplied by y, and there should be 3 such groups. So it can be written like this. And by removing brackets, it can be written like this. And let's count how many y's are there. Yes, actually there are 6 y's. So finally, we can write the answer like this, y to the power 6. And guys, there is something you need to pay your attention. That is for the index of the answer. The index of this answer is 6, and this 6 is actually equals to 2 multiplied by 3. That means the product of the two powers, 2 multiplied by 3. So with that, we can have the next law of indices, and that is about power of a power. So if it is y to the power m to the power n, so that is actually equals to y to the power m multiplied by n. Now it's time to do an example with power of a power. Here there is 3y to the power 4 to the power 3. With the brackets, you need to know that this 3, the index 3 belongs to 3, and also for y to the power 4, but this 4, the index 4 belongs only to y. So with this, we can write this like this, 3 to the power 3 and y to the power 4 to the power 3. So that can be written like this, 3 to the power 3, y to the power 4 multiplied by 3. And 3 to the power 3 is equals to 27, and y to the power 4 multiplied by 3 is actually equals to y to the power 12. So finally we can say the answer is 27 y to the power 12. That's the end of the video. Hope you guys learned all the concepts and some examples for the lesson indices.